So, good afternoon, good evening, everybody. We're going to start and jump right in, and let me share my screen. Okay. 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 So, let's get right into it. So last week we had started talking about linear regressions, and really we were looking at what we're calling a simple linear regression. I remember telling you that the reason why it is called simple is because you're looking at only one variable as a predictor. You're trying to understand how one variable predicts an outcome. So for example, we know today that smoking causes cancer. But in the 60s or in the 50s, people were not very clear. So they needed to understand how smoking predicts the risk of cancer. And someone would say, well, it's not only smoking that causes cancer. And I say, exactly. We're not saying that smoking is the only cause of cancer, but we want to know that in people, to the extent that smoking can cause cancer, how can we quantify that effect? And if you're looking at only that one variable, smoking, on that one outcome, lung cancer, then you perform a simple linear regression. Today, we're going to talk about multiple or multivariable linear regression. And so we're going to talk about when you add more than one variable. So for the people who say it's not only smoking that causes cancer, let's imagine that poor diet also causes lung cancer. Let's just imagine. You want to understand how smoking causes or predicts lung cancer. If you hold poor diet constant, meaning you want to see the effect of smoking by itself on lung cancer and the effect of poor diet by itself on lung cancer. That is called adjusting. You are adjusting for the one variable to see how the other variable predicts your outcome. And so you can have two or more variables predicting the outcome, and that is called a multiple or multivariable. You see, it's multivariable regression. We're going to talk about that today. And the thing to note is there really is not a lot of difference between the simple linear regression and the multivariable, apart from what I just talked about. So as we go on, I'm going to show you why a multivariable linear regression may be more useful than a simple linear regression. There are things that you can do and so on. Also today, we're going to look at, while we're looking at simple linear regression, we're going to look at the different ways the predictor terms can be introduced into a model. So get ready, there's a lot to teach. I might be moving really quickly so that we can touch everything equally, everything that's important. But as is my usual practice, we are also going to give some people the chance to be participatory in this class, because as I talk, I would have questions. Sometimes I have questions for Dr. Abioye, who constantly helps me out. He took time out of his Eid celebrations yesterday to answer a question, so big ups. And other times I want to talk to the people who are listening to find out what they think about the question. So if you've been here before, you know the drill. Raise your hands if you'd like to be participatory. If you know a little about regressions, we appreciate it. If you don't know much about regressions, but you want to be in the hot seat to ginger you, as they say, raise your hands as well. And Dr. Abioye is going to give you the opportunity to participate. Okay, so Musa Abbas just gave me the other house cleaning rule. If you're in a noisy place and you want to participate, please find a quiet place. If you cannot find a quiet place, please participate through the chats. Okay, let's see, who do we have here? I know that anyone who wants to raise their hands, or shall I look through the participants and start calling names? Okay, let's see who's raising their hands. I don't see any hands raised. I see a person called Bibian Robert. I like that name. I see Chidindu, and I see someone called Cliff, someone called Dr. Chaho, Dr. Ogechi, Seriki Adeni. I'm just reading people's names. Okay, so yes, I see Adio Razak Adetona. All right. Okay. So, Adio Razak Adetona, let's start with you. So if you unmute yourself, hopefully you're in a quiet place. Let's do this. So I talked about last week, I don't know if you attended the session, but whether or not, we talked about predictors and outcomes. What's another name for a predictor variable?
It's a manipulator.
Okay, I like that, but that is not the right answer. I think that we're
What about influencer?
No, okay, let's stop guessing. I think that the answer we're looking for is independent variable. A predictor variable is also called an independent variable. And the reason why I asked that question is I want to refresh our minds that the dependent variable is the outcome variable and the independent variable is the predictor variable. And why is this? Just think about it. Your outcome is dependent on whether your risk factor is present. So when we're talking about lung cancer as an outcome, let's imagine that it was only smoking that caused lung cancer. We are basically saying that the occurrence of lung cancer will not happen if smoking did not occur. And let's use mosquito bites because people might get confused and say, wait, I know that it's not only smoking that causes lung cancer. So let's use malaria. If you do not have falciparum, if you do not have falciparum in your bloodstream, you cannot get malaria. So malaria is the outcome, it's the dependent variable. Getting malaria is dependent on your predictor variable, which is your independent variable, which is your falciparum. Okay, so let's jump right in, just a little refresher. And I think the last refresher, where are we on time? Okay, I think I'm slowing things up. The last refresher, we talked about the R and the R squared. And let's see, Ms. Chidindu Okoli, I don't know your title, so pardon me. If you can unmute yourself, can you tell me the difference between the R and the R squared, or what the R is? At this point, I would take tag teams. So anyone who wants to unmute themselves and give us the answer, I see Dr. Seriki Adeni, Bibian Robert. Can you tell us or remind us the difference between the R and the R squared, or maybe just what the R is? Any takers? Okay, so maybe not. Okay.
Right. Maybe I should try.
Yeah. No guessing. I'm just kidding. Yeah.
R is the determination of variable.
Okay.
Where R square is the determination of coefficient of variable.
Okay, I kind of like that. You know, the R is your correlational coefficient, and it tells you whether two variables are associated, whether they can predict each other. Whereas your R squared tells you, quantifies how the variance or the variability in the predictor outcome affects the variability in the outcome, in the predictor variable and the outcome. And I'm getting a sense that this may be a little technical, and that's why we're doing a refresher, and then we'll bring it forward. Okay, so if you have any questions, I'm going to say this. Regressions, everything they do in research, from economics, econometrics, all the way to core bench science, is really one form of regression or another. So all this stuff about COVID drugs, blah, 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 they're doing regression. So these things are technical. So if you don't understand the thing, you can raise up your hand and say, hey, let's understand. It's better that you understand if we're going to spend this time together. Okay, let's jump right in. So let's talk about important variations of the simple linear regression. So let's see, let me close this so I can see. Now, the first thing, I remember what we talked about last week. We said, you know, you're predicting the outcome, and then we were using this example of whether the number of years you work as a resident is a predictor. The number of years you've served as a resident is a predictor of whether you is a predictor of how many hours per week that you worked in. Okay, at this point, I'm going to again ask if anyone can unmute themselves and ask this question: what is a continuous variable? Adeshola Modupe, can you help us with that? Do you remember, or can you tell us what a continuous variable is? Okay. Not a very responsive.
Hello, a continuous.
Okay, yes.
Hello?
Yeah.
Yeah. When we say a continuous variable, are those variables that the distance between the first variable and the next variable is kind of somewhat infinite?
It's infinite,
those,
right?
Yeah. Yeah.
Excellent. So stay right there. Okay. So when you're looking at a continuous variable, do you remember how to predict the results of a regression when your predictor variable is, your independent variable is continuous? Do you remember how we did that? Okay, can you see my screen?
Yes, I can see it. Example 5.
Okay, good. So let's look at the coefficient. Let's look at this coefficient, right? Yeah. So what is our dependent variable here?
The dependent variable is hours worked.
Hours worked, great. Yeah. What is our independent variable here? Gender. Excellent, yeah. Excellent. Yeah. What is the, so remember that in our regression, we quantifying estimates. What is the, I'm hovering over it. Okay, so can you interpret this regression model?
Okay, from the coefficients, looking at the regression equation, it means that when for each of the being a female, it means that they worked 6.6 hours less than the others.
Per week, right?
Yeah.
Less than who? Who's the others?
Less than the male gender.
Exactly. And what can you say about this quantity? Is it, should we believe it or should we not believe it?
Yes, we should, based on the p-value.
And where is the p-value?
Under less than 0.001.
Oh, so that is a p-value, but it is the p-value for the constant.
Okay.
Okay,
yeah, no, we shouldn't believe it. No, yeah, we should believe it. 0.014. It's less than
0.014, exactly. So yeah. Basically, you are saying if you are, so let's talk about the constant alone. So these are male and female residents. So you're saying that if you are a resident and maybe you are genderless, we don't know your gender, we are going to assume that you work 74.3 hours a week. If you are, no, sorry, that's wrong. Okay, so let's start with this, the female. So if you are a female resident, we're going to assume that you work 6.6 hours less than males, and we believe it because of this p-value. But Abbas, how many hours do males work? Can you tell us from this table? Are you still there? Are you thinking about it?
Hello?
Yeah, tell us.
4.3 hours.
So if you are male, you are working 74.3 hours. So here the constant is male, and the constant here is male. But if you switch from a male to a female, that constant is going to drop by 6.6 hours. Perfect. I like it. Now, this is very different from what we did last week. And I'm so sorry that we don't have the, what you call it, from last week. Do we even have time to look at it? Let me try. Okay, let me try. Pull up from last week. Unit 5, I have it. Okay. So we have to go slow because it's kind of it's kind of clear that maybe people don't get need a refresher. So let's do this. Let's go slow. This is not what we're looking for. Okay, let's look at this. Abbas, do you want to continue or do you want to tag somebody else?
So I want to continue.
Okay, let's do it. Let's do it. And if you want to help the class along, please just raise your hand. Okay, so let's look at this. We're not going to look at this a regression. We're just going to look at this, for example, because we want to save time. And so here we are saying that in this case, just reading this example, what is our predictor variable and what is our outcome variable?
Hello?
Yeah. Can you hear me? Yeah.
Yes. Yeah. The predictor variable is the gender.
No, wait, which of my screens are you looking at?
The one you, okay, for this, but I thought you are referring to the class we are doing for today.
No,
okay,
no,
for
this one.
last week, okay, for the last week, okay, the the predictor variable is the exercise.
Exercise. And is it exercise or is it the is it
the time spent on exercise? The
time spent on exercise. Okay, it's exercise for 30 minutes. Okay, let's go. Maybe this is not a great example. Sorry. Let's do this one here. I want to show you how the difference between a the interpretation of a continuous variable and a non-continuous variable. So let's look at this one here. And so sorry, but we're back to something similar. What is our dependent variable here?
Okay, the dependent variable here is the hours work.
Hours work. So it's the same as what we just looked at. But what is the predictor variable? And what is another name for a predictor variable?
Predictor is also known as an independent variable.
Exactly. And so what is the independent variable here?
Resident years.
Residence years. Okay.
Residence years.
Okay, so let us imagine that a resident can be a resident from time 0 till time infinity, and that there is no there is this infinite between 0 and 1. Okay, so let's go straight to the interpretation. How will you interpret this regression table?
Okay, based on the regression table, each resident, irrespective of the years spent on practice, spent at least
Yeah, go, I like it.
Okay, spent 70 hours each resident
per week, right?
A week. But for those okay, spend 70 hours a week, but those that have I'm finding it difficult on how to say
it's okay, and that's what I'm trying to highlight.
7 hours, yeah.
Right. Okay, so let me, so this is remember when we did male and female, we said if you work, if you are we were using female as the predictor, not just gender, but gender being female. And we said that because we are assuming that there are two genders in the workforce, male and female, the constant is automatically male if your predictor is female. So males will work, I believe it was 74. And then if you are female, you will work 6 hours, 6.6 hours less than your males. Now, when you come here, however, when you are using a continuous variable, you're saying irrespective of your years of residency, you will be expected to work 70 hours per week. But how do we interpret this? We're saying that for every year increase in residency service, that is how you interpret for continuous. For every unit increase in your predictor, for every year increase, because the unit for your predictor is years, for every year increase in your predictor, your number of work hours per week will increase by 0.97 hours. That is the difference for every in continuous. The way you interpret it is for every year increase, for every unit increase in your predictor. Okay, so Abbas, do you want to give it a try? Let's imagine that I'm a second year resident. How many hours per week will I? You don't need to do the math, just tell us. How many hours per week will I work?
Okay, it will be around 72 hours a week.
Right, because, yeah, tell me.
Because this is each unit, each hour will result in increase in 0.97 hours.
Each year, right?
Each year will result in increase in 0.97 hours. So 2 years will be 2 times 0.97 hours, which will approximately be 72 hours.
Right, and then you add that to 70, and
yes,
that's what gives you. But do we believe this?
No, because
Why?
of the p-value.
Which of
because
them?
Of the p-value is for this for the resident years. Because of the p-value is less than is greater than 0.0171. So
it's greater than what?
Is greater than 0.05.
Exactly. And what is 0.05 called?
The alpha value.
The alpha value. That is our threshold value. Anything greater than that, we will reject. We will fail to reject the null. Yes. Fail to reject the null. Excellent. Excellent. Okay, so we've done this, and Abbas, you are on a roll. I think that you're doing great. Excellent. Thank you so much. Let's come back to today. Where's today? Slide 6. This one. Yeah. Okay, let's come back here. Does anyone have any questions? Would anyone like to try this? Please feel free, raise up your hand, unmute yourself, because it's like I said earlier, it's better if you understand it than if you just attend the session without understanding it. Okay, so let's see what's in the chat. 30 minutes. Okay, there's people answering. Onyegiri Chukwu Ebuka said correlational coefficient. So I'm guessing that's the answer to when I asked what is the R. So do you want to unmute yourself, Chukwu Ebuka and Temi Oladejo, because Abbas is having all the fun, and let's make sure that we're spreading the happiness to everyone. So Dr. Abioye, if you can unmute those two people, we will move. Okay, so we're here, and let me close this one. So we've seen when the predictor is continuous. We've seen when the predictor is binary. So binary just means only 2 levels. You are either male or female. That's binary. Let me ask a morbid question. No, I wouldn't ask it. I'll just tell you. So you're either male or female. You're either dead or alive. You know, like if your outcome, when you're looking at outcome for surgeries, your patient is either dead or alive. That's binary. You say, did you eat today? Yes or no. That's binary. If your answer is either 1 or 2, that's also binary. Now, here's the thing. So I've told you what a continuous variable is. There's infinite numbers of steps between any 2 points in the continuous variable. I've told you what binary is. There are only two levels: yes, no, 1, 2, 0, 1, you know, dead or alive. Now, a binary, and this is my opinion, but the basis of what I'm telling you is true. A binary variable is also a categorical variable. And some people might say maybe not, but think about this. In a categorical variable, you have 3 categories. So you have 2 or more categories, right? So you can either be, if you are dead or alive, those are 2 categories of existence. You're either dead or alive. It's categorical. Your car can either be yellow, white, or red. Those are 3 categories. Your BMI status could be normal, your BMI could be overweight, your BMI could be obese. Those are 3 categories. So but there is a difference in the interpretation of, there is a slight difference in the interpretation of non-binary but categorical variables. We've already seen that we've already seen how to interpret continuous. We say for every 1 unit increase in the X, and that's in the predictor variable. By the way, people would call your predictor variables your X variable. You know, your Y is your outcome, your X is your predictor. So it's the X variable, it's your predictor variable, it's your independent variable. There's some other thing, it's your covariate variables. So and we can use those interchangeably. Now, so let's look at another example where it is categorical, but it is not it is where it is categorical, but it is not binary. So look at this example here. We're looking at the number of children. Now, something else, something I told you again last week was that sometimes in statistics, we make a lot of assumptions, you know? So someone would say, we can treat the number of children a person has as continuous, but it really is not continuous, because hopefully there's nobody that has 2.5 children. There's no one that has 2.1 children. So children is more of, the number of children is just like the number of teeth in your mouth. It's discrete. You either have 1 child or 2 children or 3 children. You can't have 2.001 children. But in statistics, we make a lot of assumptions. If you can count the variable, like 1, 2, 3, 4, 5, people say, okay, let's model it as continuous. So let us look at the number of children. So does anyone want to unmute themselves, or do we continue with Abbas, Temi, and Chuku Ebuka? What do you guys think? Okay, maybe we continue with Musa Abbas. Musa, are you okay with that? Oh, by the way, we're not paying Musa Abbas anything. He's just fantastic. So thank you so much for agreeing to do this. So you can unmute yourself at any point. You're muted. So let's look at children. So now we're looking, oops, our dependent variable is still the same. We're looking at hours worked. Our independent variable is the number of children. So we're saying here that irrespective of the number of children you have, we're going to say if you have 0 children, not irrespective, but if you have 0 children, you are going to work 72 hours, 72.16 hours. But this coefficient is saying that for every child, because we are treating this as a continuous variable, for every increase in children that you have, for every 1 unit increase in children you have, your work hours will reduce by 0.3. But look at our p-value of 0.81. It is almost 1. So we fail to reject the null. The null is that the number of children you have has no relationship with the number of hours you work. So we do not believe these figures. We say the number of children, we fail to reject the null. That means we basically accept the null that the number of children you have does not affect the hours worked. Look at this table here. We're going to come to it in subsequent slides, but just take a good look at it. Okay, so now, why does this keep moving? So here we have model children as though it's continuous, but personally, I don't know if this makes sense to do this, because like we know, children are kind of not continuous. Okay, even though we can assume. And when you look at a lot of papers, you're going to see assumptions like this. Don't say that, oh, this is bad regression. There are reasons why people do make these assumptions, and you might make them yourself as you go on. Okay, let's look at this. So we see, so this is exactly what we're saying. We fail to reject the null of no difference in hours worked. We conclude that the number of children was not significantly associated with the number of hours worked. So remember what we're talking about, predictors. So if you were an employer, and this is, of course, this is against the law, right? Or should be against the law. But let's just use it as a bad example. If you were a hospital administrator and you wanted to employ residents, and you say, Dr. So-and-so, you have 10 children or you have 5 children, and so we don't think you will be able to keep up in this hospital. And somebody's going to say, excuse me, sir, remember our study. It showed that the number of children that the person has does not affect the number of hours they work. So it's not the number of children that will determine. Why don't we use some other criteria? Please don't use male and female. We know that it was significant, but if you do that, you will get into a lot of trouble.